And we are going to actually sketch some graphs, okay? So on the bottom of page 10, they talk about all these different features. Now, some of them are more helpful than others when it comes to sketching a graph, okay? Domain, it says the values of x. Range, the values of f of x. You know that. Intercepts. Intercepts, if I can find my pen here. The intercepts, I want you to circle that. You hopefully know that's where the graph crosses the x or y axis. If they give you an intercept, you need to plot that point. Okay? Jasmine, head up, please. Keandre, come on. So the intercepts are very important. All right? End behavior is also important. Okay? And finally, the extrema. So those three parts that they explain to you in a sketch are very important. The intercepts are going to be specific points. The end behavior tells you whether or not your graph is going to end up going up or down. And the extrema is going to give you some actual points also. So intercepts, end behavior, and extrema. All right, let's turn the page. And it says we need to sketch a linear function. What does it mean to be linear again when you're drawing a graph? Are we going to have to do some jumping jacks to get you guys awake? How about walk around the class? Okay, then everybody, let's get your heads up. Those of you that have your heads up, thank you. Jasmine, come on. Keep your head up. What does it mean to be linear? What's the word inside the word linear? Line. Yes, we are talking about a straight line. So use that to help you. If it says it's linear, it's going to be a straight line. All right, so here is an important one. Y-intercept says it's at 0, -70. You need to plot that. So 0 stays at 0 on the x-axis, and then we drop down to -70, which is in between -60 and -80. Okay? So we've done that one. Linearity, it says it is linear, so it has to be a straight line. We have to keep that in mind. All right, then it says it is positive for values of x where x is less than -30. Okay? Positive for values of x where x is less than -30. So find -30. This is kind of a point that they're talking about here. Less than -30. Here's -30. And for everything that's less than that, it says it's going to have a positive value. Okay? It also says it is decreasing. It is decreasing, and you read math like you read words in English. You read from left to right. So it's decreasing for all values of x. That means from left to right, it's going to be going down. So from left to right, it's decreasing, so it's going down. All right? And then finally, it says, this is the end behavior. This is the really important part too. As x is going to positive infinity. Which direction is positive infinity? To the right or to the left? To the right. As we are going to the right, my y values are going to negative infinity. That means it's going up or down? Down. And the next part, as x is approaching negative infinity, as I go to the left, my y values are going to positive infinity, which is up. Now, we have those 2 points there. A line only needs 2 points. Okay? So, connect those 2 points with a line. Somewhere up here, I think I have a really cool feature, but I cannot, for some reason, reach it. So, this line is going to look something like this. And you can check it. So there's my y-intercept, 0, -70. It is linear, as straight as line as I can make. Positive for values where x is less than -30. It is above this 0, so that is positive at -30 or less. It's decreasing from left to right, it's going down, and the end behavior matches up also. Okay? What questions do you have about that? Because you are going to have to draw these. All right, let's go to example 2. This says we are sketching a nonlinear. Nonlinear. So what does that mean? Nonlinear means it is, come on. Is it a line or not a line? It's not a line. It might have a curve, not a line, not a straight line. All right, so here we go. Y-intercept, very important, on the y-axis. 0, 3. Oh, wait a minute, I don't have a 3 there. So you need to mark it in between the 2 and the 4. Okay, there's that. It is continuous. Okay, so that means you're going to have arrows on the ends. It's positive for all values of x, decreasing for all values of x where x is less than 0. Decreasing for all values of x such that x is less than 0. Okay, we'll come back to that in a minute. Extrema, that's one of those 3 important things. You want to do the intercepts, extrema, and your end behaviors. This says there is a minimum at 0, 3. Minimum at 0, 3. 0, 3. Oh, we already have that. So your y-intercept and your minimum are the same. Okay? These right here, they are the same. So that is your minimum. This is the lowest point. Okay? The lowest point. Now, take a look at the end behavior. This is the other important one. As x is going to positive infinity, which direction is that? To the right or to the left? To the right. Your y values are going up or down? Up. As x approaches negative infinity, that means it's going to the left. Your y values are going up. All right. So they're not giving us a whole lot here, but if I go to the right, I need to go up. If I'm going to the left, I need to go up. This is my lowest point, so my graph that I'm going to make looks like this. Now, let's go back and see. Does this have a y-intercept of 0, +3? Yes. I can make a check mark there. Is it nonlinear? Is that a straight line? No, so it is nonlinear. Is it continuous? Does it keep going because of these arrows? Yes. Is it positive for all values of x? These are my x's. This would be an x value of 0. It's positive. It's above this line y equals 0? Is it decreasing for all values of x such that x is less than 0? So when x is less than 0, it is decreasing up to that point. Okay? So this ticks off all the boxes, and that is your graph. Okay? Any specific questions about that? All right, let's go to the one at the bottom. Example 3. This is going to be a real world function. Real world. All right? So follow along as I read. It says test drive. Hay is test driving a car she is thinking of buying. She decides to accelerate. What does it mean to accelerate if you're in a car? Yeah, speed up. Go faster. So she's going to speed up to 60 miles per hour and then decelerate to stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed and 15 additional seconds to come to a stop. Use the key features to sketch a graph that shows the speed y as a function of time. So here's my speed on the y-axis. Here is time on the x. Almost always you will have time on your x-axis. Okay? So let's look for the important features. Y-intercept. Okay? That's one of the important ones. She starts her test drive at a speed of 0 miles per hour. She starts her test drive at a speed. Well, she's starting it, she is at time 0, right? And she is also starting at 0 miles per hour. So we're going to put a point at that origin. Go ahead and place a point in that lower left-hand corner. All right, it says linear or nonlinear. This function models a situation that is nonlinear. So it is not going to be a straight line. Not going to be a straight line. Extrema, that's an important part. Hay's maximum speed is 60 miles per hour, which she reaches 15 seconds into her test drive. So it takes her 15 seconds, okay, to get to a top speed of 60. Well, let's find 15 here. 15 seconds in on the x-axis. And she reaches a maximum of 60 miles per hour. Here's the 60 over here. Here's 15 seconds. Here's my 60. And so I'm going to go up to the 60 and place a point right there. It takes her 15 seconds to reach a maximum of 60 miles per hour. Okay? Increasing. It says, Hay blanks the speed at a uniform rate for the first 15 seconds. Hay blanks the speed. Well, if she starts at 0 and she ends up at 60, what is she doing with her speed? It has to be doing what? Increasing, right? So Hay increases. She increases the speed at a uniform rate. A uniform rate. So that means her speed is going to look like a straight line, at least for that part. It's uniform. It's not jagged like this. Okay? It is uniform. All right. Decreasing. Then she decreases the speed at a blank rate for the next 15 seconds until she reaches a blank. What do you think? She decreases the speed at a blank rate. Do you think it's going to be a jagged rate? No, it's going to be uniform. That's just like your slope. When you're talking about slope, it's the same slope. So she's going to decrease her speed at a uniform rate for the next 15 seconds until she reaches a stop. So she's going 60 miles per hour, and over the next 15 seconds, so at 15 seconds, what's 15 more seconds plus 15? 30. So that means at this 30, 0, she's going to reach a stop. She's doing it at a uniform speed, and so that means it is going to be a straight line down. So, end behavior, because Hay starts at blank miles per hour. When she first starts, how fast is she going? When you get in a car, how fast are you going initially? 0. You start at 0 miles per hour, and she ends at 0 miles per hour. Therefore, there is no end behavior. Kind of a weird test drive. Yes. I'm sorry? Yeah. Any questions about that? The y-intercept was important, the extrema was important, and the end behavior. Those are the things that are most important. Okay? All right. Let's turn the page. We have one more example. I want you to see what you can do with this one on your own. So look at the intercepts. Look at any extrema, maximum, minimums, and look at the end behavior. Okay? See if you can draw this sketch on your own. Chauncey, right? Okay, this is your second one. You only have 2 more for the whole semester. And they took a skills check yesterday. Maybe you can take it tomorrow. Okay, if your head is down, you need to be working. Come on, people. Got to practice this. It doesn't just come to you. You see a lot of ordered pairs up there. Make sure you are putting down those ordered pairs. Come on, you need to try it. Hey, Keandre, come on. You haven't done any of this? Hey, Rashawn, come on. All right. Did you already? Oh, it's up there. Oh, okay, okay. We don't got no points. We got no points. All right, so let's take a look. Let's see how you did. I see people putting points down, which is good. Then you kind of need to connect those points. So it's nonlinear. It says nonlinear. So not a straight line. That's important to keep in mind. Increasing where x is greater than 1, we can check that later. I got x and y intercepts here. I have a minimum, meaning the lowest point, and I have n behaviors, okay? So y-intercept at 0, -3. So 0, 1, 2, 3. That takes care of that point right there. A x-intercept at -1, 0, -1, 0, and 3, 0. 1, 2, 3. Okay, so I've got those. And it says a minimum. That means what? Low, high, right, left? What does that mean? Minimum. Low. I have a low point at 1, -4. So there's 1, -4. So I've got those. My n behavior. That's a good one to look at too. You got your intercepts, your maximum mins, your n behaviors. As x goes to the right, f of x, my y values are going up to positive infinity. As x goes to the left towards negative infinity, my y values are going up. Okay, so putting this all together, I need to go up and up from my lowest point. This was my lowest point. So I need to just connect those points. And right there is your graph. Okay? All you can do is plot the points they give you and then take a look at what it tells you for the end behavior. What questions do you have about that, if any? How many got all the points in there? Did anybody get all the points at least? Nobody's raising their hand. All right. Any questions about anything on this sketching of graphs? You will have at least one of those on the test. What period? Yeah. Okay. All right. We have some time left over. Your homework is homework number 3. It is on sketching graphs. Okay. And this is actually going to be due tomorrow. Tomorrow. Okay. So we have this. Homework number 3 is due tomorrow. You still have the weekly Canvas activity for this week. Some people have started it and sent that to me. But let's go ahead. Let's take out homework number 3 right now. And let's take a look.